look at some guided notes for arc length and sector area. Let's look at the first two formulas. I've gone over these before, but just to review, arc length is based on circumference, so it's going to be 2 times pi times radius times measure over 360. Just in case you're wondering, that's an M for measure. Sector area is based on the formula for area and is pi r squared times measure over 360. Just basic review there. Okay, so let's go ahead and look at a couple of examples here. Now here's the fun part. We're going to give exact answers instead of estimates, so that's the only difference from how we have covered this before. Look at an example for arc length. So you see here how we have a circle. The radius of the circle is 5 feet. What is the length of a 90-degree arc? So if our circle is 5 feet, let's just go ahead and write down the formula. The formula would be 2 times pi times radius times measure over 360. Substitute for all known variables. Well, we know radius is 5, and we know our measure of our angle is 90. So we're going to go ahead and put in 2 times pi times 5 times, and then we're going to do 90 over 360. Simplify. So easily we can tell that 2 times 5 is 10, so this front part becomes 10 pi. And then here's the fun part, 90 over 360. You could just simplify that as a fraction, but if you think about it, 90 degrees is 1/4 of the circle. So if you divided this up into fourths, then you would just have that 1/4 left right there. That wiggle got a little crazy. So it's just 1/4 actually simplified. That's all you have to see it as. So we'll go ahead and put 1/4 there. So essentially you have 10 pi over 4, which can simplify down to, if you even both of those out, we can change that to 5 pi over 2. Works out pretty good, huh? Okay, let's go ahead and look at another example of arc length. Here we have that the radius of a circle is 6 kilometers. Once again, let's remember our formula is 2 pi times r times measure over 360. And then we're going to go ahead and substitute all known values. We know that 2 times pi times the radius is 6, and then our degree measure is 45 over 360. Okay, 2 times 6 is 12, so that's just going to be 12 pi. And then here's another one that we can look at. If we look at how this circle is actually divided up, that's half. This would be 1/4. And then these are going to each be 8ths because they're half of the fourths. So really, if you look at it, each one of these is 8. 1, 2, 3, 4, 5, 6, 7, 8. This is really just 1/8 of the circle. So really, we can just put 1/8 here. That's what 45 over 360 simplifies to. So you have 12 pi over 8. But these are both factors of 4. So we can go ahead and simplify that further down to 3 pi over 2. That's just simplifying 12 over 8 to 3 over 2. And that gives you an exact answer, 3 pi over 2. Alright, so let's look at sector area on the back page. So that's the blank that you're looking for right here, sector area, in my best handwriting. Okay. The radius of a circle is 1 inch. What is the area of a sector bounded by a 180-degree arc? First of all, formula for sector area is pi r squared times measure over 360. We know pi times r, which is 1 squared, times, and then we have 180 over 360. Now we're going to simplify. 1 squared is just 1, so really that's just pi times 1, which is just pi. And then the fraction part. Well, you could simplify 180 over 360, or you could just look and see that we really just have 1/2 of the circle that's shaded. So really, this is just going to be 1/2. And if you take 1/2 of pi, that's just pi over 2, or pi divided by 2. So that's your final answer, pi divided by 2. Alright, one last example to look at here. The radius of a circle is 1 mile. What is the area of a sector bounded by a 135-degree arc? First of all, formula for sector area is pi r squared times measure over 360. Plug in for known variables. Well, we know pi, we know radius is 1 squared, same thing as last time. And then our degrees is 135 over 180. The only different part about this is the degree measure. Once again, you could just simplify 135 over 360 and figure out what that equals as a simplified fraction. But if you just use a little bit of common sense, you'll see what I'm talking about here on this. So first I divided up into fourths, and then I divided up into eighths, because I took my fourth and I divided that in half. So if you think about that, what fraction of the circle is shaded? We have 1, 2, 3 sections, and each of them is an eighth. So really what you have is you have pi times 1, well that's not going to work. Pi times 1 squared times basically 3/8. 1 squared is just 1, and 3 and 8 don't simplify any further, so your final answer actually is just going to be 3 pi over 8. Final answer. Okay, so I wanted to show you a couple of examples of how to work these in the simplest form. Sometimes you give exact answers in the simplest form, and sometimes you give estimates like we have been doing. But either way, you need to be able to do both. I pulled these off of iExcel to kind of give you a preview. So the final part of the assignment is to go to Quizzes and use this join code. Some of them are going to be asking you for exact answers, not simplified, and then some of them will be asking you for estimate answers. Just read the context of the problem and figure out what it is that they want you to do.